Everyone's talking about AI agents like they're magic, autonomous, thinking, alive almost. So let me ruin the magic trick in one sentence. An AI agent is just a loop. That's it. Strip away the hype, and the thing powering every autonomous AI agent you've seen is one of the oldest ideas in programming. A while loop wrapped around a language model. In the next few minutes, I'm going to build that loop with you piece by piece. You'll see exactly how an agent goes from chatbot to something that acts. We'll watch a real one solve a real task, live. And by the end, you'll understand why people have started calling the new skill loop engineering, and why it's quietly replacing prompt engineering. No magic, just the loop. Let's get into it. Start with what you already know. A normal chatbot. You type a message, the model reads everything so far, and it predicts the next response. One question, one answer. Then it stops and waits for you. That's the key word. It stops. A plain language model is a brilliant one-shot machine. Ask it something, it answers, and the story ends. An agent breaks that rule. Instead of answering once and stopping, it answers, looks at the result, and asks itself a new question. Am I actually done? Or is there a next step? And if there's a next step, it goes again and again until the job is finished. So the difference between a chatbot and an agent isn't a smarter model. It's the same model, put inside a loop and given a way to act. Hold on to those two ideas, the loop and the ability to act. We're going to build both. Quick but important question. If an agent is just a loop around a model and loops have existed forever, why is this only blowing up now? Because for years, the loop didn't actually work. You could wrap a language model in a loop and ask it to use tools, but the model wasn't reliable enough. It would invent tools that didn't exist, mangle the inputs, or confidently loop in circles. The idea was fine. The engine was too weak to drive it. What changed is that the models got specifically trained to do this, to look at a menu of tools and produce clean, structured requests to use them. The moment tool calling became reliable, that old loop suddenly held together. That's the unlock. Not a brand new idea. A finally good enough engine inside a very old one. Let's build it. Step 1. We gather everything the model needs to know right now. The goal, the conversation so far, anything it's already learned. Call that the context. Step 2. We hand that context to the language model. And often, before it does anything, the model reasons. It thinks out loud about what to do next. Then it produces a response. But here's the twist that makes an agent an agent. That response isn't always a final answer. Sometimes it's a request. The model says, before I can finish, I need to do something, look something up, check a calendar, send a message. So step 3 is a simple question we ask every single time. Did the model ask to use a tool? Yes or no? If the answer is no, there are no tool calls. It just gave a final answer. We're done. We break out of the loop and hand the result back to you. But if the answer is yes, the model wants a tool. We run it, take the result, add it back into the context, and we loop. Right back to the model, now a little smarter than it was a second ago. People have a name for this rhythm. Reason, act, observe. Think about what to do. Do one thing, look at what came back. Then go again. And that's the whole engine. Context in, model reasons and responds. Run any tools, feed the results back. Repeat until there's nothing left to do. If you've ever written code, you already recognize this. It's a while loop. While the model still wants to use a tool, keep going. People build elaborate frameworks on top of this, but the beating heart underneath is about 5 lines of logic. That's the part nobody shows you. It really is just a loop. Let's open up that run a tool step, because this is where the second idea, the ability to act, actually lives. And it's more clever and more boring than people think. A language model can't really do anything. It can't open a browser or run code. All it can do is produce text. So how does it use tools? Before the loop even starts, we hand the model a menu. Each tool on that menu has a name, a plain English description of what it does, and a little form describing what it needs. Here's a tool called Search. Here's one called Send a Message. Here's one called Check the Calendar. Here's what each one expects. Now, when the model wants to act, it doesn't do the action. It fills out the form. It emits a neat little structured message that says, "Call the tool named search with this query." That's it. The model's entire superpower is deciding which tool to call and with what arguments. Then your system, not the model, your code, running on your machine, actually executes it. It runs the search, gets the results, and drops them back into the context as a new message. The model reads that result on the next turn and decides what to do next. That separation is the most important thing here. The model is the brain that decides. Your code is the hands that do. The agent is the loop that keeps them talking. And this pattern is basically universal now. Whether you're using one big AI Labs model or another's, the shape is the same. Define tools. The model requests one, your system runs it, the result goes back. Once you've seen the loop and the tool calling handshake once, you've seen how every agent works. Enough theory. Let's watch one of these loops actually run, with something anyone can picture. I give an agent one instruction. Plan me a weekend trip to Lisbon and keep it under $800. Watch how the loop chews through it. Turn 1. The agent doesn't have a plan yet, so it reasons. The biggest cost is flights. Start there. It uses a search tool to look up flights. Your system runs that search and hands back a result. A round trip for $450. Now the agent knows what it has left to spend. Loop. Turn 2. New information. New decision. It reasons. 450 spent. 350 left. Now I need a hotel that fits. It searches hotels and gets back a place at $90 a night. 2 nights, $180. So far, so good. Loop. Turn 3. Before it commits to a plan, it does something a good agent always does. It checks its work. It reasons. Are those dates even free? It checks the calendar. The weekend's open, and it adds up the total. $630. Comfortably under the $800 limit. Turn 4. The agent looks at the situation. Flights bookable, hotel found, dates free, under budget. There's nothing left to do. No tool to call. And remember the rule. No tool calls means break the loop. So it stops and hands you a finished plan. Look at what just happened. Nobody told it those steps. We gave it a goal and a menu of tools, and the loop turned a vague wish into get flights, find a hotel, check the dates, total it up. Done. That's not magic. That's reason, act, observe. 4 times around the loop. Okay, I told you it's just a loop and that's true. But I'd be doing exactly what I made this channel to not do if I stopped there and let you believe agents are easy. The loop is simple. Making it good is genuinely hard. Here's where the difficulty actually hides. First, when does it stop? Our trip planner stopped cleanly because it hit the goal. Under budget, dates free. But a loop with a bad stop condition doesn't finish a task. It spins forever. Calling tools, burning money, chasing its own tail. Knowing when the job is truly done is surprisingly subtle. Second, what do you feed back in? Every loop, the context grows. In a long task, it balloons, every tool result piling up. Dump in too much and the model gets lost, slow and expensive. Too little and it forgets what it was doing. Deciding what the model sees on each turn is half the battle. Third, what happens when a tool fails? The search comes back empty. A website won't load. A good agent notices, adapts, tries another way. A bad one confidently marches off a cliff. And because it can act, a wrong move isn't just a wrong sentence. It's a real email sent to the wrong person, or money actually spent. Which is exactly why serious agents add a few more dials. Hard limits, so the loop can't run forever. A budget so it can't burn unlimited money. And for anything dangerous, a human checkpoint. The loop pauses and asks before it does something it can't undo. And notice, none of that is the model's job. It's the loop's job, which brings us to the punchline. For the last couple of years, the skill everyone chased was prompt engineering, wording your one message to the model just right. In a one-shot chatbot world, that made sense. The prompt was the unit of work. But in an agent, the prompt isn't where the magic is anymore. The loop is. What tools you offer, what you feed back each turn, when you stop, how you recover, where you put a human. Those design choices decide whether your agent is brilliant or useless. The single prompt barely matters next to the shape of the loop around it. That's the shift people are now calling loop engineering. You stop being the person who carefully prompts the model and start being the person who designs the system that prompts it over and over on your behalf. It's early, the name might still change, but the idea is real, and it's where this is all heading. So here's the whole thing, with the magic removed. An AI agent is a language model, given a menu of tools, wrapped in a loop, that runs until the job is done. The model decides, your code acts, the loop keeps them talking. That's the machine. Next time someone tells you an agent is thinking, you'll know what's really happening under the hood, a loop turning, one tool call at a time. If this made the loop click, that's exactly what this channel is for. Taking the newest AI everyone's hyping and showing you how it actually works. Honestly. Subscribe and stay in the loop. Next episode, we open up that tool menu and look at the standard that's quietly connecting every agent to every tool, MCP. See you there.